Right. Okay. So we're going to start off with do now. Do now activity just to get your brains working. We've got 5 questions and a star question there as well. I'm only going to give you 5 minutes. Don't worry if you don't get all 5 done in that 5 minutes. Just do as many as you can do in that 5 minutes. That'd be great. Thank you. So 5 minutes. And timer has been started. Unfortunately, we're not going to be using the hands up feature because there's no way the chat's been disabled. Yeah, the chat's been disabled because unfortunately it wasn't used appropriately last week. So all questions, if you could just leave to the end, that'd be great after the recording has stopped. So if you've got a question now, just think, maybe write it down and hopefully I'll be able to answer it at the end. Another good option as well is obviously you've got any questions you can ask your teacher through Show My Homework or Satchel, whatever it's called these days. That would be another good way of getting your questions answered because your teacher should hopefully know you more individually than myself. Obviously, I've got all of year 7 here. So yeah, you can ask your teacher via Satchel. And you have, where's my timer? 2 minutes and 20 seconds remaining to do as much as you can do. Within the last minutes of the do now activity. And that is your time up. Don't worry if you didn't get all the questions done. Again, if you can always watch this back if you're determined to do a few more questions, just try to ignore some of the answers if you want to do them at a later time. And today is going to be a great day to do some home learning. It's forecast to rain all day, so you've got plenty of time to crack on with some maths or any other subjects. So let's go for the answers. Question 1. The answer was 54 weeks. Why was it 54 weeks? Because we knew that 1 week was 7 days. Therefore, a certain amount of weeks, that's what A stands for, a certain amount of weeks, would be 378 days. How do we find out how many weeks that is? Well, what am I times in 7 by to get to 378? I can find that out by dividing 378 by 7. And therefore, I can work out that it would be 54 weeks in total. Perfect. Question 2. Your answer is 26. Why is it 26? Well, if I look at a number line and I look at 15 and 4 and 15 and 26, you can see that's the same distance. So I forgot what the actual question is. Question 3, t is equal to 8. Why is t equal to 8? Well, t plus 28 plus 3t plus 40 equals 100. How many t's do I have in total there? What's my total amount of numbers? Well, we got 4 t's in total and we got 68. So 4t plus 68 equals 100. Then if I take away 68 from both sides, I end up with 40 equals 32. And if I've got 4 lots of something equals 32, I can just divide that by 4, and 1 lot is going to equal 8. It's quite an advanced question, that one. Question 4. Remember to mute your microphone if you're just joining. Thank you. Question 4 was minus 19. Minus 19. Why was it minus 19? Well, we have to do a multiplication first, order of operations. So minus 9 times by 3 has to be done first, and minus 8 times by minus 1 must be done first before our addition, because multiplication and division has a higher priority than addition or subtraction. If I do my multiplication here, I've got 2 negatives. Multiplying 2 negatives makes a positive product. Now we've dealt with our multiplication, we can simply do our addition. So minus 27, adding 8 makes minus 19. Question 5 is 95. Why is it 95? Well, that's because the 3 angles in a triangle add up to 180 degrees. I think it's a triangle. 28 degrees plus 57 plus something equals 180. I can add my 2 digits together to make I have to make a number and take away from 180, or I can think of it as 180 take away 28 take away 57 to find out my missing angle, which is 95 degrees. And lastly, the star question, if you had to go at that one, we had an answer of no. Why is it no? Well, if you look at my 2 sides here, I've got I think a triangle has a base of 10 and 2 sides of 6 and 3. And if you notice here, we've drawn 2 circles either side. These would never meet these 2 sides. If you notice, 6 plus 3 is 9, so it can't actually reach the other side of 10. So therefore, the sum of the 2 shorter sides must be greater than the other sides. Otherwise, you just don't make a triangle. There we go. Let's get on with today's lesson. So we're going to be working alongside the work booklet today, starting to look at coordinates. We can use coordinates to describe a location on a 2D space. 2D space just meaning a flat surface. A coordinate consists of 2 values, an x ordinate, that just means what the x number is, and the y ordinate, that just means what the y number is. But now I need to fill in the blanks here. So there's something that describes a horizontal location, and there's something that describes a vertical location. The origin is the point something. Okay, so if we're thinking about the horizontal location, that means going from side to side, going across horizontally. So my mouse is going across horizontally right now. To describe the horizontal location, the what describes the horizontal location. Well, it's the x ordinate. So anything going across horizontally is represented by this number line, which is the x-axis from -4 to 4 here in the diagram. And the something describes the vertical location. So describe the vertical location, if that would be the y ordinate. Again, that's just the value of y in my coordinate. And that describes anything vertically, which goes from top to bottom here. So my mouse is going across the vertical y-axis. And the origin. So origin just means the center. And as you see here, the center where we've got x ordinate is 0, the y ordinate is 0. So the point is 0, 0. So the origin is always 0, 0. You'll hear that thrown across in some questions as you go through assessments all the way up to GCSE. It will refer to the origin. Sometimes it will refer to 0, 0. You just have to be used to using both bits of language. And also 0, 0 looks like a little bit of a face there, doesn't it? How about that? So for example, the points -3, positive 2 is a point 3 spaces to the left. So I'm starting from the middle here, 3 spaces to the left from the origin, and that gets me to here, but also 2 spaces up from the origin. So we're going across the x-axis by -3 and up the y by 2. My x ordinate is -3. My y ordinate is positive 2. Lovely. So that's the concept of it all. So what is the coordinate position of the fly on the grids? So what would the coordinate? So now I'm using the word coordinate. Ordinate refers to one number, but coordinate brings the two together, so the x and y value together. So really quickly, I want you to have a think. Where is my fly on this coordinate grids, Coaxian grids? So hopefully most of you thought or wrote down the answer 2 for my x value, my x ordinate, and 2 for my y ordinate. So here I really should have been consistent with my language. I should have said x ordinate and y ordinate. Together they bring me a coordinate. So this is my coordinate 2, 2. And you'll notice the x and the y have a different scale. That's fine. That can happen. That's not a problem as long as the x scale stays consistent with itself and the y scale also stays consistent with itself. So you wouldn't, for example, have 1 going across here, which is a wide one, and then use this scale to get to my 2, because that would be not in keeping with the rest of the axes. Right, now where's my fly? Don't know what we're using the fly, but why not? I suppose because flies buzz around our house all the time, don't they? What's the value of my, where's my coordinate for my fly now? Just really quickly think about it or write it down. Either is fine. So hopefully you thought I'm going across my x-axis by -3. So my x ordinate is -3. And I'm going up my y-axis by 1. So my y ordinate is +1. Again, I should have been using the word, I shouldn't be using the co here because we'll actually bring the two values together at the minute. Which means my coordinate for the fly now is -3 and 1. So our x value always comes first and our y value always comes second. So if you got 1 -3, you just made a little bit of mistake. You got your values correct, but if you actually put 1 -3, you're actually down here. So you can see it's in a completely different location. You're going across 1 and down -3. So just be careful which way round you order your coordinates. Now where's my fly? A little like 12 seconds, have a little think. Where is the coordinate? What's my x ordinate? What's my y ordinate? What does that make the coordinate? Lots of the use of ordinate in this lesson today. Right, so hopefully you found that your x ordinate, which looks confusing because you're like, well, it's not here, it's not anything negative, it's not anything positive. Hopefully most of you discovered it's in line with the origin. So actually my x ordinate is 0. My x ordinate is 0 because we're not moving in any direction on the x-axis. And my y ordinate is -3. My x ordinate is -3, which makes my coordinate 0 minus 3. Perfect. So your coordinate doesn't always have to move on the left and the x-axis left to right, or the y-axis up or down. So we have a look here. We've got different axes, as the title says, option 1, option 2, and option 3. You'll notice that in option 1 we go up by 30 each time. Go up by 30 each time. In option 2 we're going up by 5s, which is all completely fine. It depends what information. It depends what information you're given. So if you're given values which are really big, you're going to have to. There's no point increasing by 1 each time, is there? So sometimes it depends what information you are given. Really quickly, do you want to try and find out the coordinates of A through to F? See if you can work them out quickly. See if the scale has tricked you a little bit. So for those of you who might be struggling to start here, let's have a little look at A while everyone else finishes B through to F. So A, we're going along our x-axis by 2. So our x values, our x ordinate is going to be 60. And we're going up the y-axis by 90. So our y value is going to be 90. Y ordinate is going to be 90. So the coordinate for A would be 60, 90. If you struggle with that one, see if you can apply it to the other two options. And hello for those who've just joined us. We had a couple join in the last 5 minutes. Now up to 32, which is slightly less than last week. Just 30 more seconds. If you need more time, remember you can watch this back. You can pause it where you need a bit more time, etc., etc. I know, unfortunately, for some people, I'm probably going a bit too quick, and for some people, I'm probably going a bit too slow. Again, having all of year 7 in here is just what we have to do for these live lessons at the minute, I'm afraid. Okay, and let's go through the rest of these answers here. So B, do I actually have the answers for these, or do I talk through? So A, as we already went through, was 60, 90. B, we had 150 and minus 60. C, we had minus 20 and 50. C, there's a little typo here, minus 20 and minus 15. So there's a little bit of a typo there. That should be minus 20. D, we've got minus 15 and then minus 40. So D is correct. E, minus 20, positive 10. And F, 15 and 40. So just, this is a nice little bit of highlight here for part C. Even as a maths teacher, if we rush our answers, sometimes we can make a little mistake here. So always be careful with your negatives. What direction is it going? And always double check your answers. But well done. So you now should be able to do pages 52 to 53 and questions 1 to 5 in the work booklet if you're here for the full duration of the lesson, of that section. If not, you can watch it back. Now we'll go look onto line segments. So a line segment, we've got our concept corner here. This should also be in your work booklet. We can put it together if you've got it with you. A something is a portion of a something that connects 2 points. For example, the 4 line segments above are the same something. They can be generated by changing the position of the same something triangle. So a line segment is a portion of a, so a line segment is just a portion of a line. So on coordinate grids, if you have an equation of line, which we're not looking at currently, it sort of goes on infinitely, but a line segment is just part of that line. So this line here that I'm dragging around the cursor, this would carry on going infinitely, but we're just looking at this small portion, this little line segment of the whole line. So for example, the 4 line segments above are the same. What is the same? What is the same? If you actually look at all of them, they're all going up by 3, across by 1 in some sort of method. So they're going to be the same length. And they can be generated by changing the position of the same right angle triangle. Because if you think about it, every single one of these, if I was to join these points up, they would create this right angle triangle, wouldn't they? And they'd all have the same length. Hypotenuse, which is a word which you'll get used to as you go through your maths career. Yeah, we'll work with that. So what I want you to have a look at here is to put the line segments in order from the shortest to the longest. Explain how you compare their length. So most of you guys should easily be able to sort A, C, and E into shortest to longest, but B, D, F, and G takes a little bit more thinking. So I'm just going to give you 35 seconds. 35 seconds, maybe 45 seconds. I'll be generous. Okay, and let's have a little look at how we would order these line segments. So obviously from E, C, and A, you can see that E is the shortest, C is the length of 3, A is the length of 4. Nice and easy to order. But B, D, F, and G are a little bit more complicated. But with a little bit of thinking, we can get our heads around them. So A is obviously going to be the longest. C is going to be smaller than A, and E is going to be even more smaller. Smaller than C. Yeah. Now I need to look at B, D, F, and G. So if we look at B, this has to be longer than 3 squares, doesn't it? We're going across 3, but it's going up by 1. If you imagine like a ladder, I'm not sure if many of you have used the ladder before, but you think about a ladder, if you're laying it flat on the floor, or any sort of plank of wood, and as you lift up from one side, it gets further away from that point that you lifted. So if you imagine this 3-line hitter being picked up as it got picked up, by the time it was like at this same angle as the line B, it'd be shorter than the line where B is. So this line has to be longer than 3. So we can say that this line here, line B, is going to be longer than C, because it has to be longer than 3 lines. Perfect. We can use that same sort of thinking with the rest of them. So let's have a look at the rest of these, D, F, and G. First of all, looking at D, again, this line here, this line segment has to be longer than 2 lines, 2 squares. And F has to be longer than 4 squares. And if you look at G in comparison to F, it still goes along 4, but the height is greater. It goes up by 2. So this length here, G, has to be longer than F as well. So D is going to go there, F's going to slot in there, and G is going to be even more longer than F. Only fractionally, only a little bit, but it is going to be longer. Perfect. So as we change this angle from this base here for B, if, for example, this line B was going up all the way to the very top there where my mouse cursor is, you can see that it's going across by 3, but the length to get there is going to be much greater. That would also be harder to compare with the rest of them. You'd have to use another skill probably called Pythagoras, which you don't look at until it's either year 8 or year 9. I can't remember how they've rearranged things, especially with everything that's going on. But now you should be able to do page 44 to 55 in your work booklet and questions 1 to 5. Right, midpoints. So midpoints, mostly referring to line segments that we were just looking at a minute ago. So something of a line segment is a point that divides the line segment into something parts. For example, the midpoint of the line segment connects the points something and something is something. Right, why are all these somethings? So, first one, a midpoint of a line segment is a point that divides the line segment into 2 equal parts. That makes sense, doesn't it? So if I have a line segment that is 4, just a horizontal one, which is 4 across, then the midpoint of that's going to be in the middle, which is going to have 2 and 2 either side. So, for example, the midpoint of the line segment connecting the points 4, 3, which we have in a diagram, 4, 3, and -2, -1. So the line segment you can see on the screen is 1, 1. So if you look here on the diagram, my cursor is 1, 1 is in the middle of these 2 points here, and we've used these 2 lines here, which indicate that this section here and this section are equal in length. Quite often you see that when you're looking at your shapes, with like isosceles triangles, equilateral triangles, etc., etc. So, moving on. So, what we want to try and do is find the midway point. So, this is a skill we need for midpoints coordinates. The midway between 2 and 18, and -7 and 5, and -40 and 70, etc., etc. So, because of time, I'm just going to talk you through this. So, we've lost one though. Between 2 and 18, it would be 10. Okay, why would it be 10? Well, what's the distance between 2 and 18? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's a space of 16 between these 2 green arrows. What's halfway between 16? It is 8. So if I count across 8, I should get to the middle. 1, 2, 3, 4, 5, 6, 7, 8, and I do. Okay. It gets a bit more complicated with negative numbers. So again, difference between -7 and 5. This is where your number lines are quite useful. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the difference between these are 12. So the difference between -7 and 5 is 12. Half of 12 is obviously 6. So I count across my -7. 1, 2, 3, 4, 5, 6. And my midpoint is -1. The third one down would going up in increments of 10. So we look from -40 to 70. I'm going up in 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120. Double check that. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. There we go. We always have to double check because I can't count apparently. So 110, what's half of 110? That's a little bit tricky to do. What's half of 100? It's 50. What's half of 10? It's 5. Bring it together, 55. Now let's count up to see if it's in the right place. 10, 20, 30, 40, 50, and 55. So there shouldn't be a 1 there. It should just say 15. It's not 115. Little typo there. It should just be 15, not 115. There's another way of doing this as well. So that way it always works, but another way of thinking about it, if I look at my two numbers here, on the vertical axes, we've got -8 and 6. Now, if I was to add these two numbers together, 6 plus -8, sometimes a bit tricky if you have negatives in there. Another way to think of this is 6 take away 8. It's the same calculation, which is -2. And then if I divide that number by 2, I get my answer, which is should be -1, not +1. Let's use that method with all of these. Make sure your microphone is muted or you'll be removed from the lesson. Go back to this one here, the top one. 18 plus 2 is 20. Hopefully you agree. And then 20 divided by 2 is 10. We got our answer. 5 plus -7 is -2. -2 halved is -1. 70 plus -40 is 30. 30 divided by 2 is 15. And again, there's that typo there. It should be 115. And we also already checked the last one. There is a method for doing this. It looks complicated, but it's exactly the same as what I just spoke through. So the midpoint of M of the line segment from P would simply be your P coordinate and you have a P coordinate. Essentially, all this means is you add your two x coordinates together and you divide it by 2. That's what that line over 2 means. You add your two y coordinates together and you half it. That's all it means. That's exactly what we're doing in the last example. So let's see what that looks like. So for example, find the midpoint of the coordinates 3, 7 and 5, 3. So we put our two x values in. That's what x1, x2 means. 3 and 5, and we add them together. And our two y values, 7 and 3. That's all that y1 and y2 means. And we divide it by 2. We half it. Okay. So in this case here, 3 plus 5 is 8. 7 plus 3 is 10. And then we half it to get our midpoint, which is 4, 5. Simple as that. Add your x's and half it. Add your y's and half it. And we get our midpoint of those two coordinates. So your turn. Find the midpoints of the following pairs of coordinates. I'm again keeping track of time. So let's just say 2 minutes. 2 minutes to see if you can find the midpoints of those. If you do all 3 in those 2 minutes, you can challenge yourself by just making up 2 of your own coordinates. and trying to find the midpoint. $20 left. Don't worry too much. Again, you can watch this back and the YouTube link I'm going to post out if I'm going too fast. There's just a lot to get through this week, that's all. And that is time up. So hopefully you've at least attempted 1, maybe 2, and 3 for some of you, which would be great. So question A is 4, 7 would be the midpoints. Add your x's, add your y's, and half it. B would be 5 and 8. And C would be 3, 4. So well done if you got those correct. Moving forwards, we're just going to use the application of midpoints now, but you should now be able to do pages 56 and 57 and attempt the questions 1 to 6 in your workbooklets. So just a concept corner for this one, because this is just the application of midpoints. It looks very confusing, but essentially it is just midpoints. So we can use our understanding of 2D coordinates to form shapes. So obviously if you connect together 3 coordinates, you create a triangle. 4 coordinates, you create some sort of quadrilateral. So the one on the board here, they have created a rhombus, maybe a parallelogram, from the midpoints of these 4 coordinates. So in the example above, 4 lines form a rectangle, which you can see around the outsides here. 1, -1, 5, 5, 5, 5, 1, and -1, 1. The something of the line segments have been joined to form something else. So let's see what we get. First of all, we need to find our midpoints of these 2 coordinates. So what would be the midpoints of 1, -1, 5, and 5, 5? Well, we add our x's together, we add our y's together, and we half them. 5 plus -1 is 4. Half that, we get 2. 5 plus 5 is 10. Half of 10 is 5. Oh, we're doing the words first. We'll come back to that. So in the example above, the 4 line segments form a rectangle. The midpoints of these line segments have been joined together, as you can see, and have joined to form it is a rhombus. So a rhombus, but both sides are equal. Opposite angles are equal. So now there's our 2, 5 that I was talking about earlier. Again, a midpoint of 5, 5 and 5, 1. You can actually see that the value for x doesn't change at all, does it? 5 plus 5 is 10. Half that is 5. Well, we're over here, but as you can see, our x value stays the same. Same as this one here, our x value stays the same. It will just essentially find out the midpoint of our y's. And at the bottom there, again, our y value stays the same at 1, but our x value, the midpoint, is exactly the same as the midpoint of our x value up here, 2 and 2, which makes sense because they're on the same x ordinate, and these are on the same y ordinate. But not too long spent on that one, just a quick concept corner. Hopefully you should be able to go at questions 1 to 5 on page 60 to 61. Next, we're looking at equations of a line. We're only looking at horizontal and vertical, though, I believe. So we can describe a something on an ordinate grid using a something. The equation y equals 3 describes a line through every something with y ordinate something. The equation x equals something describes the line through every point with an x ordinate 4. Can we fill in the blanks here? So we can describe a something on the coordinate grids using a something. So we can describe a line on a coordinate grid using an equation. So any line you can draw at all. Again, we're only looking at vertical and horizontals, but any line at all we can describe using an equation. So the equation that's on the screen here, y equals 3, can be described as a line that goes through every point with a y ordinate of, what do you think? We can see here, all the y ordinates here is 3. So y equals 3, every single value, doesn't matter what the value of x is, y is always equal to 3. So the equation x equals something describes a line with every point with an x ordinate of 4. So that would be x equals 4. And the coordinate where they both meet, where y equals 4 and x equals 3 meet, is 4, 3. And that makes sense because there's an x ordinate of 4 and a y ordinate of 3, which we're describing over here, which brings the coordinate together as 4, 3. And we're just filling in our equation of lines there, which we spoke about earlier. Perfect. So equation of lines, we have 4 lines there on the screen. Every point in the green line has a y coordinate of 2. That means the line has an equation of y equals 2. Every point in the red line has an x coordinate of -3, which means the line has an equation of -3. That all makes sense. Really, we should be saying y ordinate and x ordinate if we're going to keep our language consistent. What describes both the blue and orange lines? What describes the blue and orange lines? You have just 20 seconds to try and come up with an answer for that. Again, you can write it down or just think of it if you want. Okay, so our blue line would be x equals 4 because every single point has an x ordinate of 4, and orange is y equals -1. Again, because every single coordinate on this line here, y is equal to -1. I'm aware of time, we've only got 4 minutes left, so yeah, firstly you should be able to do these pages for these questions. There's one more section left, which I don't think we'll have time for. So I'm just going to flick through these pages. So you might be able to look back over the YouTube video when it goes up and pause at certain times. So we were looking at exploring horizontal and vertical lines, which is applying what we did last time in that last example. The blanks, so you might be able to look back when shapes are drawn using the coordinate grids, we can describe the lines of symmetry using equations. So, for example, here, line of symmetry is here for the kite for the value y equals 3. That makes sense. Symmetry. Again, we can explain the lines of symmetry using for this rectangle here, x equals 16 and y equals 10. The cross through the middle, let's just find the midpoints of the coordinates here. Hopefully that means you can attempt these questions 1 to 6, 66 and 67. I know that's really rushed through, so hopefully you can go back and have a look at a later time through the video. There is an exit ticket, but like I said, there is literally a couple minutes left. So if you could, a little bit of homework when this gets uploaded later, have a go at the exit ticket, and then using Satchel, if you could send a message to your teacher to let them know what you got on your exit ticket out of 3. So for example, if you did 2 out of 3, when I show you the answers in a second, you could write and say to, let's say, Miss Anta, from the live lesson today, I got 2 out of 3 on my exit ticket. It just gives your teacher a bit of an idea of how you're doing with these live lessons. Here are the answers. Don't look at them if you want to do it at a later time. And that hopefully means you can do these Heggerty maths tasks. So that is it for today's lesson. I'm just going to stop recording as soon as I can find a stop recording button.